Good evening and welcome to C Biology, the cover page. This is Mr. Wilson, CSEC Bio HSB Live, and we're streaming from Kingston, Jamaica. We are a little behind time, or a lot behind time, as a result of some connectivity issue, but we're here as promised, and let me extend my gratitude to all those persons who have been here, who trust the system, so to speak. Shania Gray, I'm seeing Vivek there. I'm also seeing Joyous. Good evening to you all and welcome to the show. We're promising our last show that we're going to be looking at respiration this evening, and we're going to be looking at the breathing system and, of course, some diseases that affect the respiratory system. Nothing has changed. It's pretty much the same thing. We're going to be going straight ahead with that, after which we're going to be looking at a past paper for those persons who are doing exams Friday. We're going to be looking at bits and pieces of a 2016 Human and Social Bio Multiple Choice paper. We have been asked to do a couple of paper 2 for both bio and HSB. We're going to be doing our best to ensure that that comes to reality in short order. This weekend, we took the time, as we said last week, to do some promotion. So we're like out of town doing promotion to, of course, see if we can reach that 50,000 students that we want to reach to ensure that we improve the quality of the passes for the Caribbean, and of course, for us to have more persons who are pretty much engaged in biology from probably grade 9 or grade 7 as we try to put the content up and not, of course, to have it all skewed just to one set of persons. Now, if you're here and you're without a friend, I suggest that you call your classmates, send a message now. Uh, Let the thing be viral. Put it on your status. We are here. We should have been here from 5:05. We have not been able to join you at that time. We're not able to join you at that time, but we are here now. As promised, you're waiting for us on a Sunday, and wherever we are in the world, whatever it is we're doing, if it means a minute left in the show, we are going to join even to say thank you. So we're looking at the respiratory system, and the first thing, good evening, Treasure. The first thing we want to find out, Treasure, I'm not sure I know that name. Treasure, where are you from? Forgive me, guys, I have to do my roll call. I like to know where you're from, Jamaica, what Caribbean island. I want to know, Treasure, tell us where you're from. Are you Jamaican? Or where in Jamaica are you if you're Jamaica? Kevin, big up yourself. How you doing? Sorry for being late, guys. Elaine Thomas Treasure, that sounds like a Jamaican name. Tell us where you're from. Are you adult learner? That's it. Those are the category. Adult learner. You're from another Caribbean island or from whichever Jamaica. Okay, you're Jamaican. All right. Sir, she is my classmate. We are from Jamaica. He is Hey, big up yourself. He is Clarendon. I'm coming from Clarendon just now. I'm coming from what's the name of that scheme? Longsville. Do you know Longsville? His is just down the road, so you must know Longsville. Macmillan, big up yourself from St. Vincent. We're a little late. We were out of town. We were in the parish of Treasure and De Sosa. We were in Clarendon today, and we had some connectivity issue, and we had to head on back here to meet with you guys. All right, so if you have not yet called your friends, it's time to do so. Ensure that you call your friends, those persons who were here earlier, and they have left, just call them over. We're here. We live at Monimus Housing Scheme. Oh my, that must be a way down. I think I'm going to take the journey down there one Sunday to see if I can find it. I think the furthest I've ever been, I have been to that saltwater place. Yes, I've been down there. But as far as Monimus, I'm not too sure where Monimus is. And I think I went down Rocky Point or somewhere down there. Yep, not so far. All right, we're talking a little bit about Jamaica for those persons who don't know. Crystal Mackenzie, good evening. Yes, we saw you yesterday on the boulevard, Crystal Mackenzie. How you doing? You traveling? Yes, we saw you at the bus stop, Crystal. Big up yourself. We have eyes all over the place, Crystal. All right, we live, all right, after you pass Beer Technical High School. All right, I don't know Beer Technical, but I definitely going to come down there. I know Beer pretty soon. All right. Love Crystal. Anyhow, it's good to have you this evening, though, Crystal, and it's good to have everyone. We want to jump right into the topic of the day. We want to know about the respiratory system. Dejanay White, big up yourself. You're here. Love you guys. All right. We want to know what is the respiratory system. For you, what comes to mind when we talk about the respiratory system? Type it in the chat. It's going to be an interactive session. So I'll be asking a lot of questions, and you're going to be probably researching or typing what you know, and we do the correction and move forward. I'm not going to be telling you everything. So I want to know what is the respiratory system. Now, after we would have known what is the respiratory system, the other thing I'd love to know, how is the air cleaned and warm before it gets to the lungs? All right. So how the body clean this air, and how is it that this air get warm before it gets to the lungs? That's one of the things that we want to find out this evening. Yanni Boo. Yanni Boo, I don't know. I want to know my viewers. Yanni Boo, who's Yanni Boo? Where's Yanni Boo from? Sir, the system in human that extract oxygen from the air. That definition, Mackenzie, is missing something. So let's go again with that. Yanni Boo, everything that deals with breathing. That is like a band-aid, like an antibiotic. You just deal with everything. But we have to start and make it be something a little more pointed, a longer tail, so that we can like eat on it and everybody will know exactly what we're talking about. So the respiratory system is a system responsible for gaseous. Hi, Yanni Boo from St. Mary. Big up yourself. I'm seeing you for the first time. Welcome to the show, and we're happy that you're here. All right. So the respiratory system is a system which is responsible for gaseous exchange. And I like to talk about gaseous exchange because when we talk about breathing, we're talking about air. Now, while we're talking about air, we're also focusing our zeroing in on oxygen and carbon dioxide. Before I dive into the respiratory system, I want to make something clear. While I said in my last lesson that 78% or 79% of nitrogen is taken in the body and the same amount is out. In some cases, you are going to see literature that is shown that it shows that we take in 78% and we actually exhale less than we took in. Now, the reason for that is because this nitrogen would have been dissolved in water, the water that we are exhaling. All right, so the nitrogen that is not accounted for, it has been dissolved in water. So the respiratory system, as we started saying, it is this system that is responsible for gaseous exchange in organisms. I'm not going to be saying human. It takes oxygen from the air we breathe, and air we breathe, remember air is a mixture of gas, and remove carbon dioxide and water from the body, which were, of course, made in respiration. So the respiratory system is taking oxygen from the air we breathe in order to use it for respiration. And then it is actually removing carbon dioxide and water, which are products of respiration, and it is leaving the system. But the question here, or the big question for the evening, is how is it that the body clean this here? Because we have been talking about pollution. We talk a lot about air pollution. And I'm sure that you have driven on the road or you've probably been on the football field and it's all dirt, it's all dust, right? And I'm sure that you were still breathing for some time, right? But this dirty air, so to speak, does not get to the alveoli. So how is it that the body gets rid of this dirt air? How is this air cleaned up before it gets to the lungs? Because if we were, of course, there are cases where we have that problem. We're going to talk about that. But no, on an average day, a windy day, a dirty day, every day, you're in the town and suspended particulates is in the air. How is it that the body deals with that air? Sir, by... I don't understand what's that. Look at that again for me, Kevin. I don't know if you want to write because of special ear, and I don't know what you're talking about when you say special ear, because you have to use the terminology for the topic. So let's look at that. Now, if you're there in distant land, as I love to say, remember to like, share, and of course, subscribe. If you want to be a part of the conversation, it's very important that you subscribe. So, Moy Lawrence, good evening. How are you doing? Mucus trap the dust. Okay, a lot's been said there, but that's a part of the answer. Kevin Mackenzie, my bad, sir, by special ear in the nose. What special ear in the nose, Kevin? We're going to hit it on the head. Amoy, you're off right. You're almost there. All right. So let's try again. So we want to find out, having looked at what is the respiratory system, we want to find out how we clean up this air. I mean, you're in traffic in the day, you're on the road, we have these motor vehicles, they are giving off smoke, which is of course is a suspended particle, which of course is a suspension. And if it's a suspension, it is suspended in the air. We have this whole lot of particulates that we are inhaling. If you were watching TV this morning, you would have learned about bauxite and the suspended particulate and the harmful particulate. So what we want to know, how is it that the body deals with this so that these particles doesn't get to the alveoli, block them up so that you can't breathe? Or there's no gaseous exchange, or there's limited gaseous exchange. We want to know that. All right, so let me just build on what Amoy and Kevin said. There are special cells that line the respiratory tract. Now, these special cells are called ciliated epithelial cell. Now, as air enters the nostril, which is lined, of course, with the ciliated epithelial cell, these cells secrete mucus, which of course help to trap these particles. And the special air that Kevin made mention of, that are called the cilia, they continue to flick, right? So they are pushing this up, and if it has passed down to the trachea, it will just push it up to the top there, up where we have the pharynx there, and what will happen is that we will swallow all of those particles. If it doesn't get that far, and it's in the nostril, what will happen? You know what will form in the nostril, and then you will take it out, all right? But remember, in order for this ear to be cleaned in the respiratory system, there's a special cell, which we made mention of earlier, which they are called ciliated epithelial cell, and they are one of the set of cells that you need to learn to draw for the exam. Now, I could make a rough drawing, but I'm not seeing my stuff here. Now, check your textbook, and you are going to look for the ciliated cell. Now, you are going to see that there are some special cells with a little nucleus and some air on top of it, and then there's one with a little other section that is a mucus secreting cell, and of course, that is the cell that is producing the mucus. The ear is actually the thing that is trapping the particle with the mucus, and the ear is sort of flicking and bringing it up back. Pretty much like you see the sea animal, it is flicking in the water, something pretty much like that, the ciliated cells, and the ear of the ciliated cells is carrying out. Now, so we talk a little bit about the ciliated cells, so it's very good that we understand about the cilia. Now, the cilia, as they are called, these are the ear, they remove the mucus and dirt particles from the ear. The ear that we're breathing in, the special ear that Kevin made mention of, and we're talking about, what we're talking about, spell the ear them for me. I'm talking about AIR. And now we want to know what ear, the ciliated cell, the cilia, there's some little ear. You want to spell them for me? All right, so we want to get that clear. So the ciliated cell, which are of course ear, that line the respiratory tract, they are going to, of course, remove the mucus and the dirt particles from the ear, thus cleaning the ear. But we want to understand, how is the ear now moistened? All right, very good. We want to understand now how the AIR is moistened and warm. Now, before we talk about how the ear get moist and warm, I want to give you a little experiment. I don't know if you have like a clinical thermometer at home, and you could probably just get some water in the mouth. So I want you to get a cup with some water. Probably you don't have to do it now, but after the show. So you get a cup with some water, and you're going to find the temperature of the water. And then you're going to, the same volume, so probably same volume of water. Don't make it be too much. Just enough water that can hold in your mouth, that type of volume you'd want to have in the cup. So you're going to find the volume of the temperature of the water in the cup. And then you're going to put some water in your mouth. And you're going to keep it there for about probably a minute. And then you are going to get it out back in a container. You probably want to get it out in a bottle, a piece of bottle. And then you are going to again find the temperature of that water. Now, when you find the temperature, I want you to account for the difference in temperature. All right, tell why there's a difference in the temperature. All right, and I want you to tell me the difference that you found probably in the next show. All right, so we want to look now at how this air is moistened and, of course, warm. Now, during the passage of the air through the nostril, it is warm and moistened as it flows over the epithelial cell. So as the air passes through the nostril, the blood vessels are flowing very close to the epithelial cell there. Of course, the body temperature is going to help to make the cell, make the air be warm. And as it flow over this cell, of course, the air is moistened, not the dry air that we're breathing in, and it moves on through the respiratory system. Now, I want to make mention of a cell that is in the nostril, the olfactory cell. Tell me what is the function of that cell. The cell is called the olfactory cell, and it's a part of the breathing system there. Very, very important. What is that cell used for? Amoy Lawrence. Air is inhaled through the nostril and warm as it moves further into the nostril passage. As it moves through the system, of course, it becomes warm. And of course, you are going to find that out, or proof to that, when you would have measured the temperature for the water that you had in your mouth. All right, so the body temperature, the inside of the body is pretty warm. So then it is going to be warm as it moves through. Now we want to know about what is the function of the olfactory cells. Now, while you look for the function of the olfactory cells, I want you to also make mention in your notes that you need to know the diagram of a respiratory system. So you're going to check your textbook, or you're going to check with your teacher, or you're going to check the internet to ensure that you have a diagram of the respiratory system. You're also supposed to know the ciliated cell. You must be able to identify them when you see them. All right? Now, I want to take you on a journey that will show us the pathway of air to the blood. So far, we have looked at what is the respiratory system. We have looked at how the air is cleaned before it gets to the alveoli. We have looked at how the air is warmed and moistened before it gets into the respiratory surface or get to the respiratory surface. Now we want to look at the passage of air straight to the capillaries. So I want you to type in the chat for me as much as you can the various parts that the air must move through. Remember, we're going to begin with either the mouth or nostril, or the mouth and nostril. While you type there your pathway with a little arrow to show me the pathway, let us be reminded that the mouth is never a safe space for you to inhale air. Now, why is that so? It's always better to inhale the air through the nostril and not the mouth. Anybody want to quickly tell me why it's not the best thing to inhale through the mouth? I know sometimes you're not able to inhale through the nostril and you have to use the mouth. If you have to use the mouth, you have to use the mouth because we need that oxygen. But it is never the best place. So we don't want to, and then we inhale through the mouth. The nostril is a better place. Can you tell me why it's not the best place or the safest place? All right, so as you, okay, Mackenzie, the mouth does not filter air. Bing, 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 bing. The mouth does not filter the air. All right, so as a result, we don't want to inhale through the mouth. It's best to inhale through the nostril. We always want to remember that. Now we're looking at the pathway of air to the capillary and back. So the air is going to enter the mouth or nostril, and then it's going to go to the larynx. Now, some books might tell you about the pharynx, which is the back of the throat, but for the respiratory system, we mostly talk about the larynx. Then move to the larynx and then into the trachea. right? Now, right at the top of the trachea there, we're going to be having the special organ we spoke about the other day called the epiglottis. And remember, the function of the epiglottis is to ensure that food does not get into the trachea. However, if food gets into the trachea, there's always this reflex action, coughing or choking, that helps to rapidly expel that food from the trachea. Now, as the air passes the epiglottis and it gets into the trachea, then it is going to go down into a branch. I want to say a branch, and I really want you to hear this. It's going into this Y branch, and this is now when we have to start talking about left and right. Left and right. And remember, when you're looking at the exam paper and you're talking about left and right, your right is going to be the patient's left. Why? Because the patient is lying on his or her back. So if the patient is lying on his or her back and you are over as a doctor and looking at the person, then naturally your right is going to be the person's left. So after the trachea, we are going to go to the bronchus. And the bronchus is divided into two, a little Y shape. So you are going to have the left and you are going to have the right bronchus. It's very important to note this, and you're going to see as soon as I get down into the lungs why it's very important to understand the difference between the left and the right. Now, after we would have passed the bronchus, we are now getting into the lungs. We are now getting into the lungs. And again, you have to label your lungs as left and right. Left lungs, right lungs. And we're going to see this as we move through. All right, very good. After we've gotten into the lungs, the bronchus there is going to divide into some smaller vessels. We call these bronchioles. Now, for some exam paper, they might want to find out if you understand the timeline that we're building here, or you understand the passageway of air. Now, usually students become confused with bronchiole and bronchus. Now, for my students, what I say to them, count the number of letters in both words. The word that has the least number of letters comes first, as it were, here for the respiratory system. So having gone into the bronchus, then at the end of the bronchus, we are going to have some tiny sacs. We refer to them as ear sac or alveoli. Now, while the lungs is the space for gaseous exchange, the respiratory surface is actually the alveoli. Now, the alveoli is pretty much like some balloons, some inflated balloons, but these are really, really tiny balloons, and there are many of them. So for this reason, the alveoli being in that large number, that big, large quantity, it makes the surface area for the respiratory surface being very large. Now, the air having gotten into the alveoli itself has a whole lot of blood vessels on the outside. What will happen is that the air will diffuse from the alveoli into these blood vessels, and from the blood vessels into the alveoli. And now we're talking about air, but of course our interest here is around carbon dioxide and oxygen. Remember, at any time you can invite another friend to join. Remember to like, share, and of course, subscribe. Do we have any questions? Read the passageway of air from outside of the body to the blood vessels. If you have, just type it in the chat so we can address it before we move forward. We want to look at some other organs or some other parts of the respiratory system that are very, very important. One such part is a pleural membrane. One such part is a pleural membrane. And within the pleural membrane, we're going to find pleural fluid. Now, the pleural membrane is pretty much like a cell membrane that pretty much encapsulates the lungs. And the membrane also forms the inside of a rib cage. But between these two membranes, there is what we refer to as the pleural fluid. Now, what the pleural fluid and the pleural membrane does, the sole responsibility here is to reduce friction between the lungs and, of course, the rib cage. Can you imagine if your lungs were supposed to be rubbing on the rib cage like this from the day you were born? If you don't know what would happen, look at the bottom of your shoes. You haven't had that shoe since you were born. You probably have it a month or two now, and you walked down the street, and before you know it, the back of the shoes is all rubbed down and lean or something like that. So to reduce friction, as we use the cartilage to reduce friction between joints, to reduce the friction between the lungs and the rib cage, we use the pleural membrane, which contains itself pleural fluid. There are some muscles that are very, very important for breathing. There is the intercostal muscle, and we have internal intercostal, and we have external intercostal. We're going to be looking at the external later. And we have also the diaphragm. The diaphragm. In our last lesson, we actually divided the body in three parts: head, thorax, and we said that the thorax is the chest part. And then separating the thorax from the abdomen is the diaphragm. Now, the diaphragm is a pretty wonderful organ. At rest, it is curve shape, or it curves upward. At rest, the diaphragm curves upward. I hope that you are following in your text, or you have access to the things that we're talking about. Hence, we don't use the graphic here because we don't want to take you away, diffuse you so much from your textbook. All right? I don't want to act as if I'm the keeper of knowledge. I am not. All right? But do I probably know a little teeny bit more than you? But pretty soon you'll know way more than I do. All right? So the pleural membrane, the pleural fluid, the intercostal muscle, the diaphragm, the rib cage, they are very, very important in the whole breathing process. Now, there are two pairs of ribs that are right at the base here. They are not connected to the bone in the middle here that we call the sternum. Remember, I have a bone here called the sternum. They are not connected to the sternum. They are called floating ribs, and they tend to go in and out, in and out. So I want to remember those bones right at the end there. Those ribs that are not connected to the sternum, we call them floating ribs. All right. Now, the ribs has a special function, and we're going to see that when we get to the skeletal system. It's very important, not only the ribs. I have seen question on one of these papers that they are asking which of the following bones protect the lungs. The rib cage is a major bone that protects the lungs. All right, it is protecting the internal organ, though they are like pretty much spaced. Of course, they serve that protective function. So, I do hope that you're following. I do hope that you understand pretty much all I have said so far. And I'm still waiting on the function for the olfactory cells. Not getting it? Nobody? Amoy, Tanisha, Mackenzie, Laura? Anybody? Boo? Olfactory cells? Okay, the olfactory cells, they are very, very important as they are the cells that are responsible for smelling, right? And when you smell something, it is dissolved in chemicals, yeah? And that is why, in some cases, the things that you smell, you can also taste. All right, that's a fact. Things that you smell in some cases, you can also taste. Now, we're going to be looking at the lungs a little more, just for a short time. And I'm going to be looking at the lungs due to the fact that I said to you it's very important to understand the right lungs versus the left lungs. All right? Now, the right lungs is divided into three lobes. The right lungs is divided into three lobes, while the left lungs is divided into two. Now, as to the reasons, we were not asked to cover that for this lesson, but it's very important for you to know that there's a difference between the lungs. We're going to hop on right into the alveoli. Having said that, having proved to you that it's very important to know the lungs different, be it right or left, and we gave you that just now. The alveoli is a respiratory surface in human. It has a very large surface area, and it is really needed by human. Now, you must be able to answer this question. Why is it that we need to have a respiratory surface that has a large surface area? Tell me in the chat there. Why is it that we need to have a respiratory surface that has a large surface area? Sorry. Why is it that we need to have a large surface area for our respiratory system? All right. So as you think about it, we move on into movement of gases. Now, what we want to understand, how this air in the alveoli, how it gets into the capillary, and how the air in the capillary, how it gets the air sac. So gases can diffuse quickly. The big word here is quickly. Faster absorption. Diffuse is always a good word to use, and quickly, a very good word to use. Now, because as human, we have a small surface area to volume ratio, we're not able to have the air diffuse through us. And in order for gases to diffuse quickly, it's very important, on the other hand, to have large surface area to volume ratio. And that is the type of thing that the alveoli creates with the many air sacs. Now, how do gases move from the air sac into the blood vessel? That's a very simple thing, and let's talk about it. We spoke about a balloon, an inflated balloon, and I want you to have that concept in your head. Now, the capillaries around the air sac, like we have, if you were supposed to have a balloon and you were supposed to use a marker and write on the outside, just take that marker writing to be the capillaries. And there are many capillaries because we want the air to move very quickly. So it would have been many writing, many lines you would have drawn on the outside of the balloon being the air sac. So the capillaries around the air sac, right? They have less oxygen. On the outside, they have less oxygen than on the inside of the air sac, because the inside of the air sac would have been the area that is accepting that air that is coming from the trachea or coming from outside. So what you have inside of the lungs, inside of the air sac, it's going to have more oxygen. So naturally, the capillaries on the outside, they are going to have less oxygen. Now, the opposite is true. While the carbon dioxide in the blood is going to be greater, inside those capillaries than it is on the inside of the ear sac. I don't know if you're understanding. I feel like you're not understanding, so I'm going to be drawing it. I'm going to draw it with a little pen, and I'm going to show you. So I'm going to draw this thing, and I'm just drawing, magnifying, taking out one thing. So say this is my ear sac. I hope you can see it. That is my ear sac. A little thing here, like an inflated balloon. Very good. So on the outside of my ear sac, I have a lot of blood vessels. All right, and I'm showing you. I use a blue pen this time to draw it. I have a lot of blood vessels on the outside. All right, so I don't know if you can see the blue, but the wave lines are the blood vessels. While here is the ear sac, alveoli. Now, what is going to happen is that on the inside here, I'm going to put a plus sign, is going to have more oxygen. On the inside there is going to have more oxygen, more O2. So I put a plus sign. On the outside, in the capillaries, as it speaks to, in the capillaries, we are going to have less oxygen. So in the capillaries, we are going to have less oxygen. Let me not jump into carbon dioxide yet. Let me deal with the movement of the air into the ear sac, because I gave some number the other day, and I'm not too sure if you remember anything. Now, what is the percentage of oxygen in the air that we breathe in? Somebody can remind me very quickly, please. Percentage of oxygen in the air that we breathe in? Don't remember? Percentage in the oxygen that we breathe in versus the oxygen that we breathe out. All right, so some persons are saying 21, some persons are saying 22, that type of thing. Some persons are saying, definitely big up yourself. I've seen a Jawawan. You're here today. Good to see you guys. All right, very good. I am not going to tell you that it is not 22, because depending on the day, right? But the accepted value here is going to be 21% of oxygen is inhaled here. So look at this. Naturally, if 21% of oxygen is in inhaled air, on the inside here, we're having 21% of oxygen. And like Mackenzie wrote there, on the outside, we're going to be having 16%. So we are having 21% on the inside that is in the air sac, and we are having 16% of carbon, 16% of oxygen in the capillary. Now, we're now talking about the movement of air. Now, because of that gradient that is created between the 16 versus the 20 versus the 21, then you understand that air is going to diffuse from where we have the 21% to where we have the 16%. Simple diffusion. And that's pretty much what drives the diffusion of air from the air sac into the capillaries. Now, the reverse is true. How much carbon dioxide do we exhale? And how much carbon dioxide do we breathe in? I'm waiting in the chat. I'm not going to take the lesson for myself. So I want to know how much carbon dioxide do we exhale? Carbon dioxide, Mackenzie. Carbon dioxide, not nitrogen. Carbon dioxide. Any other answer? So Reed has it there that it is 4% that we exhale. But how much carbon dioxide do we breathe in? Mackenzie, today is not your day. What's happening? All right. So Jawawan, depending on the temperature of a day, it could be between 0.03 to 0.04. So you understand that there is a huge difference there. So the fact that we have now 0.03 or 0.04% of carbon dioxide in the air sac, in the air that is coming in, then naturally we having 4% of this carbon dioxide in the blood vessel, then you understand the direction that the diffusion is going to take place. It's going to be moving from the capillaries into the air sac and then eventually out of the system. I do hope that we understand that bit. All right, so we spoke about the air being moistened as we move over the epithelial cell. Now we want to look at the transport of oxygen and carbon dioxide. And I want you to pay attention to this. I just demonstrated to you how the air got into the blood and out of the blood. Joyous, good evening. Joyous, I don't know your name. Where are you from? Sorry, guys, I want to know the family members as they join. I want to know everybody. All right? Oh, Javon Scott here. Big up yourself. Javon Scott, he's a guru at it, right? It's one of my one student for last year. All right? He's at sixth form now. Hi, Scott. How you doing? Happy to have you here. All right? He's still learning. I think he's doing Cape Bio now, but he stopped by every now and then, probably just to support the system. And we love that. All right? Good. All right. So we have just looked at how the air actually leaves the alveoli into the capillary and how the air actually leaves the capillary into the air sac. And we use them interchangeably. We're using air sac and alveoli. It's pretty much the same thing. Now, the capillaries are actually the blood vessels, and they're usually one cell. Remember we spoke about respiratory surface the other day? All right, good. So now we want to talk about the transport of oxygen and carbon dioxide. And before I get into the transport, I'd like to give you all the stories that you have a real reason for learning it. You would have heard me saying in answering multiple choice paper, while we were talking about the method of elimination or whatever, there is always a story around a question. What is it that we're supposed to be using to answer the question? So on your multiple choice paper, the many multiple choice paper that I have already sent out, you would have seen question being asked about carbon monoxide and the blood, carbon dioxide as a pollutant. Today we're going to be looking at carbon monoxide, from cigarette smoking. So now you're going to have a better appreciation of this carbon monoxide being affixed to hemoglobin, because now we're going to be looking at oxygen, hemoglobin, carbon dioxide this time. Carbon dioxide and how they are transported. You don't want to miss this, because this is something that falls a lot of time in teachers' null curriculum. Big up yourself if you're a teacher and watching. Love you. I am a teacher just the same, so probably it falls on my null curriculum. Who knows? All right, so here we go. So we're looking at the transport of oxygen. So after the oxygen would have diffused into this blood capillary, it is going to combine with hemoglobin. Hemoglobin in the red blood cell. You observe me never say hemoglobin in the blood? Because the blood is a mixture. When we spoke about air, we said that air is a mixture, which means it has many different gases. And when we spoke about blood, we're also saying that blood is a mixture. It has different things in it. It has even a white blood cell and platelets. All right, we spoke about plasma and all of that. So oxygen, having entered the capillaries, it is going to be combining with hemoglobin in the red blood cell. It's very important to note that this combination gives you a bright red. Bright red. So you'll understand that when the blood is depleted of oxygen, then it tends to have a dull red color. All right? So when the oxygen combines with the red blood cell, you remember that fancy name for red blood cell? Erectocytes. Combines with the oxygen, combines with the hemoglobin, the oxygen combines with the hemoglobin, it forms what we refer to as oxyhemoglobin, which is, of course, bright red. It is the red blood cell that is carrying the oxygen. You notice I did not say blood. I said the red blood cell, which is a component of the blood. Now, the red blood cell is a pretty wonderful thing. Let me see what's happening over here. Sorry, guys, I wasn't paying attention. So, red blood cells, very good. Oxygen plus hemoglobin, you get oxyhemoglobin. Beautiful. So, it's very important too. We spoke about earlier that you had to know the ciliated cell. Yingers. Every time we have a show, there's a Yingers. I tell you, we have a lot of Yingers here in Kingston. I'm going to get myself a Yingers too. All right. So I spoke earlier about knowing the respiratory system and being able to label it more. So if you're a biology student, you probably need to draw it and label it. If you're an HSB student, then you need to label it. We also spoke about the ciliated cells that you are supposed to be able to label. And when you draw it, remember, it should have the mucus secreting cell. But we need to also know about the red blood cell. And the red blood cell, before we did that in circulation, but I want to touch it again because now is when it's very, very important to what we do. So the red blood cell is carrying your oxygen. Now, the red blood cell is something like a donut. I don't know how many persons know donut, but it has a little depression in the middle. If you want to know what a red blood cell look like or would shape like, make yourself a dumpling with some flour. I don't know what these guys what my friends in Guyana and Trinidad and Antigua and Barbados, I don't know what they call their flour dough thing. But we make something in Jamaica that we call dumpling, right? It's a dough. You could use Play-Doh to do it as well. And when you would have made a round thing and you flat it out somewhat, a disc shape type of thing, then I want you to just press into the middle and both sides, and that depression there, and then the outside of it is going to be a little fatter. That is something like the red blood cell. The red blood cell, I don't know if you're going to be able to see this. I'm not too sure where my markers are. So you observe this part in the middle, that is the depression there. And of course, the red blood cell does not have a nucleus. The red blood cell does not have a nucleus. Remember that. Now, the red blood cell is also, it is usually drawn. I do hope that my drawing here is good enough for you to see. And this is not so good, but I am sure. On the side view, they usually draw it with a little depression in the middle here, a little depression. This is too high. And then here it will show you the side view. So it usually draw, you usually see both like this on the paper. Right. So this little depression here, all right, we refer to it as a biconcave disc. Very well. So it refers to as a biconcave, bi, two side, concave, depression in. So that's why it's called biconcave. So here, this area here allows for the oxygen to diffuse readily into the red blood cell. But we spoke about where and what carries the, all right, can't see. Brittany Gray, can't see. Oh my, let me see if I can get some support. Oh, I was lying. It's right here. I found it. I'm so sorry. It's right here. I found it. It was all covered with my papers. All right, so someone can't see. That's fine. We're going to be showing it. All right, so we're going to be drawing it all over with a marker. And we're drawing something to represent the red blood cell. All right. And then we're drawing something that should actually look like the side view. All right. So we're saying here that this is actually the red blood cell. And here we have a depression. You would have seen Scott saying there the biconcave disc. And it means that there's depression on both sides of the cell here. And we're saying that in the middle here, this depression allows the oxygen to diffuse into the cell readily. Here we have the side view. And usually on a multiple choice paper, when you get the red blood cell, it's usually with both diagrams. And it's usually with both diagrams because there are other cells that look pretty much like the red blood cell. And not that you're seeing the depression, but you could mistake, for example, one of the white blood cell could be mistaken for it, and I think the egg cell could also be mistaken for it. If you have not done a lot of study, you could easily make you could easily make error there. All right. So we just spoke about. Let us I'm seeing a whole lot of new faces. Welcome, guys. You know that when you join the show, we want to ensure that you're a part of the family. So we want to know where you join from. And in every show, we're going to be looking for you. When Jawawan is not here, we know. When Matt Millan is not here, we know. When Tanisha is not here, we know. When Amoy is not here, we know. When Rihanna Knight is not here, we know. And of course, many other persons, when they are not here, we know. And after the show, we're saying, wonder if they're fine. You know, because they're family. It's family. So I want to know that everybody is fine, everybody is studying, and nobody is getting too anxious about the exam. This is a family class. When we have 5,000 persons, it is still going to be a big family. Remember to like, share, and of course, subscribe, and continue to call your friends to come on over. So we just spoke about oxygen being transported in the blood. And we said that it's the red blood cell that is transporting this oxygen. And we said that it combines with hemoglobin to become brightly red and forms what we refer to as oxyhemoglobin. So now we need to talk about carbon dioxide, don't it? Yeah, we need to talk about carbon dioxide. Good night, Rihanna Night. Carbon dioxide, it leaves the body cell as bicarbonate, which is dissolved in the plasma. You see? We just said it. The blood is a mixture. The red blood cell is just one component of the blood. The plasma is another component of the blood. Does the red blood cell travel in the blood? Yes. Does the carbon dioxide travel in the blood? Yes. But what part of the blood? It's as if I were supposed to ask you, you travel in the taxi? Yeah. But Jawawan traveled in the front seat and Macmillan traveled in the back seat. So I might have asked, did you travel in the front seat of the cab? Now Macmillan would say no. Jawawan would say yes, and vice versa. But they both traveled in the cab. But they traveled different component of the cab, the front seat versus the back seat. So here it is, carbon dioxide travels in the blood as bicarbonate dissolved in plasma. Plasma is a component of the blood. The red blood cell travels in the blood. What part of the blood? I said something wrong just now. Sorry. Oxygen travels in the blood. What part of the blood? In the red blood cell. So oxygen travels in the red blood cell. Carbon dioxide travels in the plasma as bicarbonate. The two new words are the things that you probably didn't pay much attention to. Is plasma traveling, is carbon dioxide. Please listen, and if I make an error, you tell me right there. All right, I'm saying a lot of things and I'm coming right from this big thing on my neck. All right, so the carbon dioxide is traveling in the plasma as bicarbonate. And remember, that the plasma is a component of the blood. The oxygen is traveling in the red blood cell, which is also called erythrocyte, and it is combining with hemoglobin to form oxyhemoglobin. When this happens, it becomes brightly red. So when the blood is depleted of the oxygen, then you understand that it has a dull red. Hence, the reason the blood is depicted in some books as being blue for deoxygenated blood and red for oxygenated blood. Not to say that our blood is blue. I don't even want to get into what is the color of blood today because the class is going to mash up. It's not red. All right? So let's leave that there. Morrison, how you doing? Big up yourself. Wish I could take more of you, but it just keep loading. All right, never mind. You can pick us up on the repeat. You can go to the channel. It will be there. So you can play it at your leisure whenever time you can. That's fine. All right, but it happens to me every now and then, and I understand that. All right, so I told you earlier, that brings us to the end of the transport of oxygen and carbon dioxide in the blood, how they are transported. I do hope that you got that. If not, you can play over the video however many times you wish. We spoke about the diaphragm, and I told you earlier that the diaphragm separated the thorax from the abdomen. Now, what we want to talk a bit now about, we want to talk about, I'm going to ask you to do some activity now for me. We're going to be talking about inspiration and expiration. I'm going to be asking a lot of questions, and I'm expecting everybody to take part. Please, everyone, take part. All right? You are going to get better if you practice. You are going to get better if you practice. Not everyone will get them correct, but everyone will learn. That is the most important thing, for us to have everyone learning something new. Remember, you still can call over your friends. It's free. We don't even need to know your name. Really and truly, we don't even need to know where you're from. But because of family reason, we ask where you're from so we can have this little chat, right? All right, good. So we move on right into inspiration and expiration of air. I will say that we're going to talk about the external intercostal muscle. All right. So we're going to talk a little bit about the pressure within the lungs. We're going to be talking about what happens in the thorax. We're going to be talking about what happens with the diaphragm. And at the end of this lesson, it must be a practical for you. You should be putting your hand on your chest, and you should know exactly what is happening, and you can like spell it out with your friend. If you're studying now with a friend, if you're with us with a friend, you can just do it with your friend. So low pressure within the thorax causes higher external pressure, and that forces air into the lungs. So let me go with that again. If a pressure on the outside is higher than the pressure in the lungs, then it's going to force air on the inside. If the pressure on the inside is higher than the outside, it's going to force air out. So I'm going to be asking some questions, and if you have your book and you have the respiratory system, the rib cage and the lungs type of thing, you probably want to use it to follow if you don't have it all locked as yet. All right, so let me just get right into that. An activity first. So we want to take a deep breath. You probably want to put your hands on your knees. And you want to take a deep breath. You probably see me. Let me try again. You saw that. All right, you think you are able to see my shirt. A deep breath in, and then slowly we release. Deep breath in, and then slowly we release. Beautiful. Now, from your observation, if you have to do it again, do it again. From your observation, what happened just now? Describe the movement of the chest. Just tell me what, as much as you know, what happened. Everybody, anybody can type. If it's 2 word, 1 word, type something. If it's like your belly get big, if it's like whatever you want, whatever words you want to use, it's fine. We're going to sort it out as soon as you would have said what you have to say. So we're looking at inspiration of air and expiration of air. We're looking at how the diaphragm works. We're looking at how the muscles of the diaphragm work. We're looking at the external intercostal muscle, the rib cage, the thorax, all of those things that we're looking at. But now I want you to tell me, having taken that deep breath in and exhale, what happened with your ribs? Let me start there. What happened with the ribs? Tell me very quickly. When you took good evening, what happened with the ribs? Anybody? I'm not going to be doing this by myself, guys. We're going to be doing this together. All right? So you just took a deep breath in and then you exhaled. I want you to tell me what happened as you took that breath in and as you exhaled. I'm waiting on your answer. I'm waiting. I'm listening, but I think the last week's show came up just now. All right. All right, I guess you would have typed now. I just responded to something there. Very sorry. All right, so whole lot of things said since I was away. All right, so let me see what's happening here now. When breathe in, the rib contract. Interesting. Your ribs got tightened when I breathe in. A lot of things been said. I'm not saying whether right or wrong. We'll get to that. Sir, my chest got bigger. All right, guys, to try to breathe in and track the movement. All right. You're getting a little suggestion there. All right. Amoy Lawrence. Amoy Lawrence, don't tell us about intercostal and all of that now, man. I don't mash up everybody. We soon get to the intercostal muscle thing. All right, let me see what you have there though. External intercostal muscle contract and exhalation. We're looking at the rib cage now, you know. Tanisha, big up yourself. Rib move up and out. Rib move up and out. Interesting. Tanisha, big up yourself. Good evening. All right. So let's just try that again. Tanisha, I think Tanisha has it. And we're going to be looking at that. When we inhale, the ribs is going to actually, some will say move out and up. Some will say move up and out. All right. So when we inhale, we're going to look at what happened. Definitely the rib cage raise. It's raised. So we're going to be looking at that. Somebody else type here. Diaphragm contracts. All right, a lot of things said here. We're going to be looking at everything, so we don't want it to leave. But what I want you to do before we leave here, I want you to be able to hold on. I hope that you can hold on to your chest. Or hold on to wherever here. And I want you to go. And then I want you to track that movement and tell me what is happening with this area. All right? Let me see what's happening there. Amoy, rib move upward and outward and inhalation. That is where we're going, Amoy. Big up yourself. Macmillan, when I inhale, my chest got higher. All right? Higher. Very good. And when I exhale, it flattened. Pause. Very good. Very good. Those are good observations. Very good, my scientists. Move downward and inward. The sources, remember, we don't want to just use those things loosely. We want to tie them to something. All right, okay, very good. So in inhalation, it moves downward. Come on. Look at what you just typed, the sources. Look at what you just typed. I think you have an error there. All right, so when we inhale, as is rightly said there by Tanisha and Amoy, the rib will move upward and outward. All right, when you inhale, up and out. All right, so it's like it's down like this, and it goes. I don't know if you can see that hand movement. Probably I can do it this way. So it goes all right, it goes like a plane somewhat taking off, that type of thing. So it moves out. Now the reason for that is, of course, to increase that space so that we can take in a lot of air. What are we talking about now? Space, much larger now. Everybody can relate to that. So we're taking a whole lot of air. Then it falls again, down and in. And then we exhale a whole lot of air. Now, it's very important that we have an appreciation for that. if you are putting on too much weight, this is going to be affected as to the amount of air that you're breathing in. And we're going to be looking at that when we look at some other terms that we're going to be doing in the end of the, closer to the end of the lesson. So I'm going to look at some parts now, and now it's time for you to boop, boop, be very quick. So I'm going to tell you about what happens in inhalation or exhalation, and you are going to tell me what happens in the opposite. All right? So I'm now looking at the diaphragm. During inspiration, when we breathe in air, the diaphragm flattens, move down. Remember that normally the diaphragm is like this, curve upward, but when we exhale, during inspiration, when the air comes in, it goes flat. All right? Air goes out, it goes. All right? So the diaphragm, I am saying during inspiration, it flattens. What happens during expiration? All right, very quickly now. You have to be fast on the finger now. Fast on the finger. The diaphragm flattens when we inhale air during inspiration. The diaphragm flattens. Now tell me what happens during expiration. Everybody now want everybody to type. I might have to ask Tanisha and Amoy to type last. No, everybody type. Tanisha and Amoy is not always right, you know. They are just always attempting. Right? Yeah, they get it more right a lot of times because they practice more. And you can be the same, so don't worry yourself. All right, it curves. This is only 3 persons. Come on, guys, come on. Type away. Type away, type away, type away. So we want to find out during inspiration, the diaphragm muscle is flattened. So as we exhale, what happens to the muscle? All right, so Tanisha is saying it has an upward curve when we exhale. Amoy is saying the diaphragm doom upward during exhalation. So doom curve upward. Brittany Gray is saying it curves. Curves out, Brittany, up or down. That's very, very important for the exam. Very important for the exam. Kevin is saying that it curves. We want to know if it's up or down. Jawawan, the diaphragm relaxes. And the volume, I'm not sure you're answering what we want you to answer, Jawawan. We want you to tell us. I gave you a little part, and I want you to just fill that part. We're saying that when we inhale air, we're looking at the diaphragm. The diaphragm. So we're looking at the diaphragm itself, not so much a muscle, the diaphragm. The physical thing, what you would see if you were supposed to looking at it. If you were looking at it, Macmillan is telling us about the muscle relax. We're not there as yet. You're telling us about the diaphragm muscle as to how the muscle itself works. But we are looking at what would happen just looking at the diaphragm physically, what you would see with your eyes, right? So if you were inhaling air, as you can see, what will happen is that the diaphragm, it is now doomed. If you inhale, it will flatten. As you exhale, so if you look at my hand, exhale, inhale, exhale, inhale. And you're looking at the doom being formed here. All right? That's what we're looking at. All right? It curves up. All right? Good. It sort of have a doom shape. All right? Doom. Very good. That's where we're going with this. It's very important that we understand views. I mean, I could do an entire class on views, and views is really, really big. Right? And we talk about view, we talk about dorsal, we talk about ventral, we talk about lateral, we might talk about transverse section and all of this. It's very important that you pay attention to views. All right? So if we say it curves, you need to tell me if it curves upward or downward or where it curves. All right? That's very, very important. Don't just say curves. All right? Very good. Always do that. So now we're going to be looking at the diaphragm muscle that Jawawan and I think Macmillan, I don't remember, probably answered earlier. Let us get into that very quickly. Now, I'm going to now give you the expiration. The diaphragm muscle, when you exhale, the muscle will relax. So when you inhale, what will happen? the muscle now. So when you exhale, expiration, the diaphragm muscle will relax. What will happen during inspiration? Remember to like, share, and subscribe. At any time, you can replay this video. This video will be on the channel. You can go there and watch it however many times you wish. We are, of course, covering today both human and social biology and biology. This promises to be our last lesson on the topic, after which we are going to be going to the transport system in plants for biology. And that's going to be a very quick lesson. And then we're going to be looking at the skeletal system for both bio and HSB. Now, you would have recalled that we did complete the lesson on circulation. There is a part about immunity to be covered for biology, but we're of the opinion that if we cover this part in immunity for HSB, it would have been better for the bio students. I think we're also supposed to cover distal, systole and diastole. We have not done that in circulation. We're definitely going to be doing that. I think we're supposed to be looking at blood type. I'm seeing that a lot in the end of the paper. I'm going to be looking at blood type as well. So in the next lesson, we're going to be looking at the transport system in plants. We're going to be looking at transpiration and so on. And we're going to be looking at systole, diastole, we're going to be completing circulation in animal, get into plant. And I'm not too sure how that will take us, but right after that, we're going to be going into the skeletal system, which is a very small and quick system to cover. Let me see what we would have had here. All right, so I said we're now talking about the diaphragm muscle. And we're saying during expiration, the muscle relaxes. Now, we want to find out from you during inspiration what happens. So Brittany is saying that it contracts. Martin is saying it's contract. Devon Reed is saying that it contracts. For Rita Martin, it will contract. Stuart is saying it will contract and move downward. Oh, I wish you would have stopped at contract. Let's move a little bit. Contract. Jawawan is saying that it will contract and pull down. Vivette is saying, sir, I'm an HSB student. Yeah, and you're an HSB student. So answer the question. This is an HSB question. Yes, we cover both bio and HSB at the same time. Don't worry yourself. We're doing both syllabus nicely. Trust me on that. If you don't think I'm doing that, go over and check the HSB past papers. All right, read. Yes, we know that some persons are doing HSB and some persons are doing bio. You're at the right place. Trust me, you are. All right, very good. The answers there, they were all wonderful. We're going to be moving now at the external, looking at the external intercostal muscle. And this time we're looking at inspiration. And for me, I'm going to say during inspiration, the external intercostal muscle, they will contract. Tell me during expiration, what is going to happen? So in inspiration, the external intercostal muscle, they are contracted. During expiration, what is happening to these muscles? And I'm listening very closely. I'm paying attention. And now let me go. The sources, please answer this question. Read, please answer this question. If you can't answer the question, no problem. Just stick around and ensure that you learn. All right, we're coming from your textbook. If you were supposed to go to your textbook and look at respiration and move on to the respiratory system, you would have realized that you should be able to answer these questions. And like we said, the aim is to cover respiration. This would have been our second class, but we think that we should be able to cover. All right, the question is, we're looking at the external intercostal muscle. I am telling you that during inspiration, this muscle contracts. You are supposed to tell me what happens during expiration. And we're doing well so far. I'm really proud of you guys. You're holding your own, so to speak. All right. Remember, you can continue to call your friends to come on over. Call your classmates to come on over. I want you to hold me responsible for what I do, you know. So I want many persons to come. Feel free to critique Mr. Wilson. That's fine. That's fine. That's how we grow. All right. Feel free to critique. That's fine. All right. So let me see what's happening here. Repeat questions I did. I want everybody to answer the question. It wasn't just those two persons. I'm at ACE 2. Oh, there's a lot of persons. What's the name of the teacher at ACE? What's the bio teacher down by ACE? I'm just wondering if this is one of my colleagues from college. All right. You probably could send me an email if you don't want to answer here. You could just go into the channel and send me an email if you wish. All right, Mackenzie, sir, they will expand. Expand. We're using these words, Mackenzie. Relax and contract. Relax and contract. Use those words for me now. The diaphragm contracts and enlarge. Veer. No, Jamara is at CC. Who's that Veer? I don't remember who's that Veer. No, don't worry yourself though. I'm a part of a big bio teacher group, so I'm sure it's one of those teachers. All right, so not many persons attempt to answer this question. Devon Reed. When the lungs exhale, the diaphragm relaxes and the volume of the thoracic cavity decreases while the pressure within it increases. Vivid, contract, relax, and move upward and downward and outward, sorry. The diaphragm relaxes and move back upward. All right, guys, I know you don't know what I'm doing. There is this thing that we call, when we are teaching, quick thinking and slow thinking. I am teaching you this way. There are times when you have to think slow. And if you don't practice how to manage both quick thinking and slow thinking, what will happen is that you will go to the exam and you will answer questions that are not asked. So in your slow thinking, you have to practice some self-restraint. He's asking something specific. Let me treat with the specificity of what he's asking. All right? I know that a lot of persons want to give me everything, but I don't want everything because this is not the time for everything. We're now practicing slow thinking. So you read through the question and you answer what is asked, not what you thought should have been asked, not that which you practice on a past paper, not that which your teacher gave you on an exam, but what is in front of you at the time. That is what I am now teaching you to answer. So yes, I admire the fact that you have a lot of content you can share with us, but let us practice what we are practicing, because I don't want you to go into the exam and your quick thinking thing goes up, bap! I finished the exam paper, but you fail. Why? You were thinking too quick. Slow it down. Read the questions properly. Answer what is asked. All right? Enough respect to the persons with a lot of information, but I'm just trying to explain what I'm doing here. Sometimes I tend to be a little casual, but I pretty much understand where I'm going with what I'm doing. Let's move right on. So the external intercostal muscle, and these are the intercostal muscle, during inspiration, they contract, and during expiration, they relax. Let's look at the rib cage now. Now, the rib cage, we looked at that. That was the first thing that we did when we started out. The rib cage, during inspiration, they will rise. And during exhalation, they will be lowered, or they will come down. Now, what about the volume of the thorax? The volume as to the ear hole inside of the thorax, there, the space inside of the thorax. Now, what is the volume like during inspiration? I'm not telling you anything now. During inspiration, I want you to tell me what's the volume of the thorax like, and during expiration, what is the volume of the thorax like? Remember when we started out and we did this exercise? So based on the exercise, and we know where the thorax is, and we're now asking about the volume, right? What is the volume in the thorax like during inspiration? Is it that the volume would have been increase or decrease? Increase or decrease? During inspiration, you got it there, that's a binomial. I helped you there. So during inspiration, would you say that the volume in the thorax is it increasing or is it decreasing? I'm waiting on your answer, guys. You're not upset with me now? Don't be like that. All right. Kevon, during inspiration, will increase. So Kevon is saying that it will increase. What about the other persons? I want everybody to answer. The right answers are good for us to learn, and the wrong answers are also good because that will help us to eliminate the errors that are possible. All right? So, guys, answer whether you know it or not. Try at your best. All right? Try at your best. All right? And I want all of you to be here. The guys from Veer, please come back. Please ensure that you're always here. Please ensure that you watch the video. And let me tell you how a lot of persons are on top of things when they get to the class. Discipline is a very important thing about this online class. The students here, they hold themselves accountable and they hold me accountable. I'm not here this evening and they were here waiting on me. So when we send out the class, usually when we send out the notice, I don't know what it is called. When we send out that thing on YouTube, it tells you that we're going to be having a class on Sunday. And at the end of it, it tells you what topic we're going to be covering. So those persons would have seen respiration and they would have read on respiration before coming to class. That is a best practice for this class and for any class. So if you want to come to this class and you want to look really good and feel really sharp and really feel good about yourself, when we send out this, I don't know what it is called, the thumbnail, whatever it's called. When we send it out, look at what topic will be covered and read ahead. And read ahead. All right, guys? Remember, there are a lot of persons here who are following that strategy. Every time I send something out, I ensure that at the end of it, we write in the name of the file or in the description there which topic will be covered. So as soon as you get here, you master the craft. And guess what? It's helping you to study. So when you get here and Mr. Wilson starts to talk and he gets to the part of the lesson where he's asking question, I don't remember that so well, but I read it. And you say, whoa, you see, if I just read it one more time, I would be good. Trust me. If that has never happened to you yet, just type it in the chat. Say, it never happened to me yet. Everything I remember, everything I've read, I remember. All right, good. Let me see what's happening here. Sir, please repeat. Not a problem. All right, I was talking about the volume of the thorax. And I wanted to find out from all of my friends here, doing inspiration, does the volume of the thorax, does it increase or decrease? Doing inspiration, the volume of the thorax, does it increase or decrease? So I'm seeing Tanisha is saying increase. De Sousa is saying increase. Kevon is saying increase. Gray, sir, please repeat. Knight, repeat the question, sir. I repeated. We have been a log in that area. Stuart, sir, it will increase. All right. Very good. I am definitely going to be doing that paper 2 question because I realize we have to sharpen up on how we answer some of these questions. The Sosa's, her ear is pushed out of the lungs due to, all right, the Sosa's, I don't think you hear the question. All right, never mind, but we like that. We like that. All right, participating is good enough. All right, and when you participate, if you're not on the same page that we're on, we help you. All right, you'll never ever see anybody in this room bash you. I know that's happening in regular classes, but that never happened here. Persons don't laugh after you. All right, persons help you here. All right, so we're going to be helping you. All right, so Ryan and I said decrease. Dejanay White is saying increase. Brittany Gray, increase. Not sure where is the thorax again. Beautiful, so we're going to be helping you with that. Rihanna Knight, inspiration, increase. Expiration, decrease. All right, let me just help you with some of this. So the thorax is like we're talking about an insect. Guys, forgive me, I'm helping her here. We're talking about an insect. Now, a big characteristic of any insect is that the insect is divided into 3 parts. Head, thorax, abdomen. As it were for us, this big thing on top of my neck, they call it the head. Your chest Here, if you're a male, if you're a female, you're going to have enlarged mammary gland on your chest, and that area is called your thorax. Now, as you slide down your finger, I don't know if you can see, as you slide on your finger, and this bone here is called the sternum. As you come right to the end of the sternum here, you feel a soft area. Now, this soft area with the diaphragm being curved, all this area here is called the abdomen. So this is the thorax, and then below here, we call the abdomen. I do hope I helped just now. All right. Sir, I'm just getting it. All right, beautiful. I want to know that you're getting it. That's fine. That's fine. If you knew it, you wouldn't be here. All right. Unless you really wanted to help us. So let me just give the answer for that. So the volume of a thorax will increase. And proof to that, look, I'm inhaling. See that? Space become larger. So the volume increases. During exhalation now, it is going back down. All right? So the volume decreases. All right? Inhalation, volume of thorax, increase. Exhalation, volume of thorax, decreases. Beautiful. So now we're going to be looking at the pressure in the thorax. Now the pressure in the thorax, remember when we started out, we said that low pressure within the thorax causes the external intercostal muscle pressure to force air in. So low pressure within the thorax causes the external intercostal muscle to force air in. All right, I always say that it causes the higher external pressure to force air in. It's not the external intercostal muscle. Sorry, I'm looking at my script and my penmanship seems not to be the best. All right, so with low pressure within the thorax, it causes the higher external pressure to force air in. Now, this is where we are going with this, all right? The pressure in the thorax during inspiration, does it reduce? Is it reduced or is it increased? So now we're looking at the pressure in the thorax. The pressure in the thorax. So when you are inhalation, the pressure in the thorax, is it reduced or is it increased? Might be a tough one. I hope I said it right. I hope I said it right. I'll try again. We're looking at the pressure in the thorax, right? The thorax. During inspiration, the pressure in the thorax, is it reduced or is it increased? Now type it in the chat there. And remember, all you need to do when you're studying these things about flat and curve and contract and relax, the opposite is always true for the other. So don't try to study and say, oh, inspiration is that, expiration is that. Study one side and remember that the other side is true. So if we're talking about increase, the other side is decrease. We're talking about contract, the other side is relax. You don't need to study both sides because you study both sides, that's more pressure on you. Just study one, inspiration, and the reverse is true for expiration. All right? Remember, that is always study things that the reverse is true. All right, so a lot of persons are saying here, Rihanna Knight is saying inspiration decrease. All right, the sources is saying decrease. Tanisha is saying reduced. I think we're answering a question at the top there. Reduced. What are we answering? Reduce, 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 decrease, 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 reduce. I'm not sure if they're answering the same question. Reduce. Brittany Gray say increase. A bit confused. All right, that's fine. A bit confused. So let us see if we can treat to that. Macmillan is saying decrease. All right, let me tell you the best way to treat to that. Just answer the question for me. Do you have a textbook? Who is that now? Brittany Gray, do you have a textbook? A biology textbook? Yes, no, it's fine. Tanisha, you need pressure to take out air That is why it goes out during expiration. Tanisha, do that explanation again for me. You need pressure to take out air. That is why it goes out during expiration. Tanisha, just explain to her for me. Okay, good. We were not going with the explanations, but Tanisha started, and I'm going to allow Tanisha to continue. If you have a textbook, Brittany Gray, I want you to go to respiration in the textbook. And to find respiration, you could do it two ways. You could go in the table of content, or you could go, I think, around to the index. And you should be able to find respiration. Look for the page number, find it, and then you're going to skip to where you see the rib cage and the movement and that type of thing. And that's a good place to start studying, having known that you can get to the higher level, like Tanisha, and then you do the explanation. All right, the Sousa's pressure inside the thorax and lungs will decrease. When you have to say when the Sousa's, you can't just leave it like that. We're not going to assume. You have to tell us if it's during inspiration or expiration. Tanisha, where you gone? Tanisha, where are you? You started doing something nice for me and then you disappear. Oh, I'm waiting on that. So we're talking about, we started out by saying low pressure within the thorax causes the higher external pressure to force air in. So low pressure within the thorax. If you have low pressure in the thorax, it will cause the higher external pressure to force air in. So, like Tanisha was saying, now if we are inhaling air, what type of pressure would we have inside the thorax? Remember, I started out giving you a clue. We said that low pressure within the thorax causes a higher external pressure to force air in. Now, having had that explanation, it should be able, if you remembered, that should be able to help you to answer. Tanisha, start it again. You need pressure to take out air. That is why it goes out. Pressure increases during inhalation. Understand that? Nicely said. And if this is easier to say, or you can use it to solve both sides, low pressure, if you have the low pressure on the outside of the body, outside of the thorax, it will cause high pressure to be inside. Right? And am I saying the right thing? Slow thinking. Let's go. If you have low pressure within the thorax, it will cause the higher external pressure to force air in. So when you are inhaling, we are trying to find out, will the pressure on the inside be high or low? It will be low. You will have reduced pressure. But when you are exhaling, you are going to have an increased pressure. So somebody type this in the chat for me, and let us see if we can help everybody with this. Type this in the chat for me, please, somebody. Low pressure within the thorax. Low pressure within the thorax. Low pressure within the thorax causes the higher external pressure, causes the higher external pressure to force air in. So low, we have that? Anybody typed? Let me just draw something here to see if I can explain. So low pressure within the thorax causes a higher external pressure to force air in. All right, so this is the thorax. All right, everybody doing well? And this is outside. All right. So these lines are representing the pressure. Low pressure, high pressure. Low pressure, high pressure. I'm now going to give it something else. I'm now going to label it with, I want everybody to get this, not just the definition. I don't want a person to get definition. I want you to know the physical thing, what is happening. So we have L, this is a L, and we have Z, or 2. We have L and we have 2. L and 2. We're using a letter and a number. Reading what is written on the screen. Reading what is, and let me just write on the line. I want everybody to get this. On this line, I'm going to write pressure. Pressure. All right, so you'll realize that one is high pressure and one is low. I probably need to write that for some persons as well. All right, so this is low pressure, and this is going to be high pressure. All right, very good. Once persons don't understand, we find some creative way to get it done. So here we have it. I hope you can see it nicely. On your screen, you wrote just now, low pressure within the thorax causes a higher external pressure to force air in. Now we have on this side high pressure, and on this side we have low pressure. On this side we have low pressure. Will air be moving from L to S or from S to L? Will air be moving from L to S or from S to L? So will air be moving from this side to this side or from this side to this side? So whether you want to call this SR2, I don't know. I'm looking at the screen, so it's at the back way. You might be seeing 2. So from L to 2 or from 2 to L. Where will the air be moving? Remember, there's a little rule on your screen, and it says low pressure within the thorax causes higher external pressure to force air in. And we know already, once air is coming in, that is inspiration or inhalation. All right, beautiful. Thank you all guys for typing on the screen. Thank you very much. Thank you very much. I probably would be typing here until next year. So the air is going to move from, Tanisha is saying L to S. Anybody else? Anybody else? Remember, we're using this diagram here with the rule on the screen. So I want to know if the air is going to move from L to S or from S to L. All right, based on the rule on the screen, right? And we're saying L is outside of the body, and we are saying that S is on the inside of the body. So what we want to find out, in which direction will the air move? Some person might be seeing this as a 2, some person might be seeing it as a S. So we're looking at the air pressure. We're looking at the pressure inside the thorax. And the last thing we're supposed to look at is the air pressure. And of course, air, like we're saying now, will be moved in during inspiration once we have a reduced pressure in the thorax. So the air pressure will, of course, force air in. Now, that is the story around the skeletal system. So let us just walk through the entire process now as to what happens during inhalation or inspiration. So during inspiration, we want to talk about what we know first. All right? So what we know is that the rib cage is going to raise. During inspiration, the rib cage, follow the picture that I'm painting, guys. So I want you to list them. I want you to list them on, whether you want to list it on the screen or on your paper. So we want to know this not by textbook, but we want to be able to get to the exam and know what happens first, second, and so on. So during inspiration, the rib cage rises. And see, we inhale. See that? So the first thing, the rib cage will rise. Now, when the rib cage rises, now we also know that there's another physical structure that we can relate to, right? And we know by default that the diaphragm is curved. So when we inhale, we know that the diaphragm will go down. So there are two things we know already. When we inhale, the chest will move up and out, and the diaphragm is going to go down. We know that physically. So inhale, first two things. First two things, the diaphragm will flatten and the ribs will raise. Do it physically and see if it is true. Let's go a little more. Now, sorry about this, youngers, but there's nothing I can do. When we inhale just now, you observe as somebody, Kevin, I think, said, in chest get bigger. Chest get bigger. Inhale, chest get bigger. Now, the chest having, the rib cage not having moved up and out, what would have happened is now that the space inside, let us talk about space. The space inside is increased, the space inside get bigger. So the fact that it has become a little larger than it was, then the volume also increase, the volume, the space inside here increase in the thorax. Now, if the space in the thorax is increased, then the pressure in the thorax will also be reduced. Hold on a bit. Hold on a bit. If I had an elastic band, and I was forcing something through it, right? And it can't go through. Now you'd understand that now that I'm forcing something through it, the pressure is sort of on. But if I got a bigger elastic band, then it could go through very easily. So once we have this increased space, then the pressure on it will be reduced. Once we have this increased space, then the pressure within that space will be increased. Because remember that the space was small and when we inhale it, right? Now, once we have this increased space, and of course the pressure is reduced on the inside, then naturally the pressure on the outside is going to be greater. So what is going to happen? Air will be forced inside. And when this air is all forced inside, all this activity, it actually was controlled by the external intercostal muscle and the diaphragm, right? And remember that both diaphragm muscle and external intercostal muscle both contract while we inspire. Now, for those persons who are not following, because you're probably hearing or seeing it for the first time, I do encourage you to revisit the text however many times you wish. You can watch the video however many times you wish. And if you're watching the video and you still can't put things together, just leave a comment there and I'll respond. All right? Remember again, for those persons who are in distant land, to like, share, and subscribe. Many of my viewers, they're having internet issues and they continue to come and go. All right. So we are probably the nice part of the class. This is a point in the class where we are now called upon to use our knowledge to save life. It is called rescue breathing or mouth-to-mouth resuscitation. Rescue breathing or mouth-to-mouth resuscitation. Now, for some reason, this question continues to be repeated on the question paper, the multiple choice papers. I'm seeing it a whole lot on the HSB paper. Now today, CPR, right? Yes, it's CPR. Isn't it CPR? Yes, it's a CPR. Cardiopulmonary resuscitation. It's also called it. I think that is what the piece for pulmonary. So it's cardiopulmonary resuscitation, mouth-to-mouth resuscitation, rescue breathing, all those are correct. All right? All right, the CPR, cardiopulmonary resuscitation. Yes. I hope I gave you the right thing for CPR. I hope I remember well. All right, good. Now, this is a very simple process, simpler than the process of inhalation and exhalation. And trust me, as soon as you would have studied that, you'll be fine. You will be fine. And let me tell you something, make sure that you are doing some past paper. Whether you're in grade 10, 7, whatever, make sure you're practicing. It makes better, makes perfect. Now, it's a very simple process. And these are some of the circumstances in which we do this. Usually the person is not breathing. This could happen because the person is drowning. And this could also happen because of electric shock, right? You were electrocuted and you need to have CPR, or you were drowning and you need to have CPR. Now, what is the first thing you are going to do? So you would have seen cardiopulmonary, all right? All right, good, resuscitation. So you would have seen Mr. Wilson. Mr. Wilson installed some electric stuff on his car. You want to see my car? I installed some power on the car over the weekend. And Mr. Wilson playing around in electricity, and Mr. Wilson is not an electrician. So Mr. Wilson got electrocuted. God forbid it won't happen. And you, my students, my greatest fans, you are supposed to assist with resuscitation. What is the first thing you are going to do? Type it in the chat for me. And remember, slow thinking, just answer one at a time. The first thing you are going to do, what is it? What's the first thing you're going to do? All right? Lie the victim or the casualty, same thing, victim or casualty, on his or her back. The Sousa come out now, come out strong. You see? Can't give up on anyone. One, verify scene safety. Yeah, you want to verify. All right. The truth is, you see, just one bit before we get to it. When you do any first aid course, the first thing they're going to instruct you to do is to see if there's any professional around. So if there's a nurse around, you're going to give the nurse first preference. If there's a firefighter around or a doctor, you are not going to take on this to yourself. Now we are going to just up away from the first aid course to the textbook as to the syllabus. So as it were for the syllabus, what we're going to do, the first thing is, as the Sousa said, we're going to place the victim on his or her back. And you want to ensure that it is a safe place. You don't want to put them where they are going to be electrocuted more, or they are going to be drowned, or they are going to be in danger. You don't want to do that. All right? Now, so the first thing, the Sousas, and go with what you have. The second thing, the victim is unresponsive, shout for help. Am I? You're doing first aid, the first aid course. Let us not do that. I've never seen it like that on the exam paper. Am I? I've never seen it. But what you're saying is true. What you're saying is true. Am I? What you're saying is true. But let's move with the syllabus. All right? I know that what you're saying is true. I've done first aid already, and I know that's what it is. Shout for help. But if you're trained, what kind of help you want to search? You want to shout for. Come on. You can treat with that. All right. But that's fine. What you're saying is true. So you're going to, having placed the victim or the casualty on his or her back, the second thing you are going to do, you are going to tilt the head back way. So you're going to tilt the head. All right? So you're going to use one head to press the head back, one hand to press the head back, and then what you're going to do? What you're going to do? After you've tilted the head backward, and there's something a little different here if you're drowning, because a lot of persons drown on land and not in the water. So, but for drowning, you're going to ensure, and that is something different. I don't want to talk about first aid. I'm going to talk about what's on the syllabus. All right, Jawawan, one of your hand pressing the head back and the other pushing the lower jaw upward. Very good. Very good. So first thing, you place the victim on his or her back, or the casualty on his or her back. Then you are going to do exactly as Jawawan said there, and then open the victim mouth to remove any debris. That is first aid again, but that is also true. That is also, you want to ensure that the airway is clear, and if it's the person drowning, be prepared that when that person make that cough or that gag, they are on their side for the liquid to leak out of the mouth, right? And if a person is unconscious, you want to have them on the side. But like I said, I don't want to get into, all right, check for obstruction of airway. Very good, Amoy. Brittany Gray. Then the next thing you are going to do, having done as Jawawan said, you are going to now pinch the nostril. Just close the nostril, not pinch as like that. You are going to like close the nostril, pinch it close. Then after you would have done that, what's next? So now that you have pinched the nostril close, what's the other step? What's the other step, guys? So we have placed the victim on the back. We have used one hand, as Jawawan said, pressing the head back, and then the other pushing the lower jaw upward. All right? And let me tell you something. When somebody's unconscious, they are really, really, I don't know, like sometimes the muscle like they are constricting. So it can be really, really, really difficult. It might be a difficult task and not as simple as it sounds here. I have done it already, so I can speak to it. All right? And it's an accident victim that I had to administer this rescue thing. I don't want to say CPR. All right? So the next thing we're going to do, provide rescue breathing. 1 breath every 5 to 6 seconds. What about mouth to mouth? Yeah, so rescue breathing. What is rescue breathing, Amoy? Everybody wants to know. Here somebody's asking what is mouth to mouth because they can't make the relationship between mouth to mouth and rescue breathing. All right. What's that mean here? All right, so seal the lips. Okay. The sources, YouTube flag what you said a while ago. Let me read and release it. Seal the lips over the victim, open mouth, and breathe out into the mouth. All right, yes, I'm going to show it. YouTube sometimes flags some stuff because they think that you are being offensive. Yeah, but what she says here, everybody can see it now. That's what you're going to do. Take deep breath. Jawawan, make a good seal around the patient's mouth with your mouth and give 4 quick blow in. Now, there are some little plastic device now, you see, that since the advent of AIDS, you can like put it over the mouth and breathe in it. All right. So if you're a first aider, you would have one of those. I think Amoy might have one of those, and you don't really have to use your mouth, right? Because you don't want to use your mouth and then probably there's blood on the person's mouth, or you leave worse than you went into that whole scenario. So you're going to use your mouth, as they are saying, the antiquated way, and most persons would not have this device. You're going to seal the mouth with your mouth, the victim mouth with your mouth, and like Jawawan said here, or Amoy said, it could be anywhere between 4 and 6 second thereabout. 1 breath every 4 or 5. I mean, yes. Amoy, yeah, that can be. But Amoy, I see you're doing your first aid stuff, you know. I'm sure that based on what you've written, I see what you're doing. Yes, but Amoy, remember the syllabus, all right? Cool. Because some of these stuff you're not going to find on the exam paper, but in your first aid course, you're definitely going to find them. All right, make a good seal around the patient's mouth with your mouth and give quick blow in. I have 1. I know, Amoy. Promise you start shut up the first aid, so me say, yes, medical student, take it away. Amoy, I know you have 1, man. Promise you, me say, yes, Amoy. Train first aider. All right, so we make the pinch and then make a good seal around the casualty mouth and your mouth and give 4 or 5 short blow anywhere there, and you are going to blow again after every 5 seconds. You know, so it's like 1, you know, like time it in your head, like 1, 2, 3, 4. Now, you need to know this sequence, this timeline. It appears on the multiple choice pretty often, and I don't want you to get to the exam and you would have seen this. I am not too sure how to address it. All right. So make sure that you learn this as well. Once I would have completed this, I'm sure you can go over there and look at any of the multiple choice paper for HSB, and you would have seen that it is there. All right. So now that we talk about the procedure for mouth-to-mouth resuscitation, it's very important now for you to understand how this works. Am I? You know it work? You want to tell us? I don't want to steal your show because I know you're the first aider in the building. Am I? How does this thing work? We have just spoken about the procedure. What is the biology behind it? All right. So we are exhaling carbon dioxide. I remember we spoke about we're exhaling how much? Every time you have to tell me, because you are learning. All right. So how much carbon dioxide do we exhale? And how much oxygen do we exhale? Tell me that in the chat. I'm not going to tell you this stuff. I've said it times and times again. So be reminded of how much carbon dioxide and oxygen we exhale. So carbon dioxide is, of course, expired air, or air that we exhale. And what it will do, yes, 4%. What it will do is, of course, it will stimulate the medulla oblongata. One might say the medulla region of the brain. And what this does is, of course, to tell the body to start breathing again. And how it does this, it is reading what is happening in the blood. The sensory receptor there, they are reading what is happening in the blood. And what they're saying is that the blood has too much carbon dioxide. The fact that you are putting in 4% of carbon dioxide, and naturally the body would be taking in 0.03 to 0.04% of carbon dioxide. And now you are putting in 4% of carbon dioxide. Then remember we spoke about some factors that alter the rate of breathing, and we'll look at those that increase and those that decrease in the last class. Go to volume 22. Now, you will recall that we said that if the carbon dioxide level is high in the blood, then you are going to be breathing faster. If the carbon dioxide level is low in the blood, then you are going to be breathing slower. Now, here we are saying that with 4% of carbon dioxide, you now induce or breathe into this individual, then the medulla region of the body there, the medulla oblongata, involuntary action, is going to say, listen to me, you need to start breathing because we need to get rid of this carbon dioxide. And while you're breathing that in, you are also putting in 16% of oxygen. And the person can start using that little bit of oxygen to start getting things on the way. It's the same bite that went up, going down. That's how they operate here. I don't know why. All right. So this excess carbon dioxide that you've just breathed in, stimulate the medulla oblongata. Tell them, so listen to me, we need to remove this carbon dioxide. So let us start working again, and then initiate the whole slow breathing until it becomes a little stronger. Now, the amount of oxygen given to the individual will be, of course, enough to aid the casualty or to aid the person in recovering. All right, beautiful. So that is how it works. How it works, you breathe in the air, the blood having this whole heap of carbon dioxide, sensory cell detect it, tell the medulla oblongata. The medulla oblongata say, listen to me, lungs, you need to start work because we have too much carbon dioxide here. It starts to work slowly and then eventually picks up. All right, that's how it works. Now I'm going to be giving you some fancy words, and these words are really for the students who are doing HSB. But if you are doing biology and you're alive, you want to know this. Whether you're doing biology or not, you'd like to know this. So if you're just watching in distant land and you want to be a part of the show, you have to be, of course, a subscriber of the YouTube, and or you have to have a YouTube account. You don't necessarily have to be a subscriber to my show, and you could just come on and ask questions. All right, so we're looking at the lungs capacity. We spoke about the lungs just now. Tanisha, in anaerobic respiration, would oxygen already present in cell move out of cell since there is no oxygen available? I don't understand the question. You want to ask a question again? In anaerobic respiration, would oxygen already present in the cell move out of the cell since there is no oxygen available by diffusion? All right. So I'm going to tell you these questions are having completed these definitions. If you have not found the answer, I will revisit the question. So here we go. Tell me in the chat, everyone, what is tidal air? In the chat, I want you to tell me what is tidal air. All right, try to stay away from plagiarism. Don't pull person's information and put it there and say that it is yours. It is not yours, it's yours. If you're going to use person's information, you need to source the site and that type of thing. All right, source the, yeah, give a source. All right, so we're looking at tidal air. And tidal air, it refers to the breath during normal breathing. So I have been talking to you from even, except for the time when we did those exercises. Now it is tidal air. This is called tidal air. And it refers to the breath that we take during normal. We're sitting down, we're lying down, just normal. All right, that's tidal air. And then we have the inspiratory reserve. I want you to look for that one, being that I started out. And I want you to type what is the inspiratory reserve. Then we have what is called the expiratory reserve. And this is air that is blown out after expiration of tidal air. So that is tidal here. But suppose I try to squeeze some more out. No, that is the expiratory reserve, right? So during normal breathing, I exhale. And if I try to press some more out, that would have been my expiratory reserve air that I just expelled. All right, good. So normal breathing, we call it tidal air. When we squeeze out some more, we'll call that one expiratory reserve. That's the air that is all squeezed out. And then we have what is called residual air. Residual air. And that is air that is not removed from the lungs by expiration. So we have some air in the lungs. Just like we talk about soil with capillary water, that is just not removed from the soil unless you eat the soil. Now, same thing, we have residual air, and this is air that is not removed from the lungs by expiration. So even though I moved my expiratory reserve just now, there's still air in my lungs. Still air in my lungs. Then we have what is called vital inspiratory reserve. Air is additional air which can be drawn in after expiration. Jawawan, please revisit that definition. Try YouTube and see if you get the same thing. Revisit that definition for me, Jawawan. All right, Tanisha, is it possible for oxygen to move out of cell? Yeah. But the oxygen, all right. Let me just ask you a very simple question, very quickly, and see if this is in line. Do you understand the process of photosynthesis? Photosynthesis is taking place in the chloroplast. What are the products of photosynthesis? Glucose and oxygen. The oxygen is given off by the plant as a waste product, and it leaves the plant via the stomata. So oxygen left the cell. So what I was saying to you earlier, let me get back. Oh, no, like in human. Sir, that is what my text. I know, Jawawan. Jawawan, I know. But Jawawan, I want you to also look at that same text. You're using this red color textbook. I know you're using this red color textbook. I can tell you. All right. I want you to also look at the definition that the same textbook gave you for expiratory air versus inspiratory air, and see if the one for inspiratory reserve and expiratory reserve, and see if you can detect any error there. All right. So I know the textbook you're using. The extra volume of air that is inspired with maximum effort after reaching the end of normal quiet inspiration. So look at what this source has said here, Jawawan. And you would have realized that in that textbook, there's an error. And I realized that there was an error. And for that reason, I'd ask you guys to do the research so I can point it out. I use our sort of strategy to teach, you know. So textbooks, they have errors too. And that is why sometimes we need teachers to help us while we study. Yeah, the textbook have an error. That's an error. We saw it. All right. But not coming down on the textbook. All of us have our little flaw and we make errors sometimes. Mr. Wilson make them as well. All right. So we're not coming down too hard on the textbook. Now, the final thing, I'm coming back to you here, Tanisha. Just give me 1 second. The final thing is that vital capacity is, of course, the total air that can be blown out after fully breathing in. So what that means, let me do the demonstration again. So I draw in a whole lot of air and I just blow so till there's nothing. That is vital capacity. All right, so it's a total air that can be blown out after fully breathing in. All right, good. All right, thank you very much, Jawawan, for your answer there. You would have helped. That is something that we always want to show persons, that we have error here and there. And remember, Mr. Wilson is not saying that you don't have any error. I have errors too. So I'm going back to Tanisha, and after I would have spoken to Tanisha, I am going to be looking at the respiratory surface in a fish. Then I'm going to be looking at the respiratory surface in flowering in plants. And then we're going to top the show off with the effect of cigarette smoking. All right, so good. I am here as your guide, and as much as I know, I will give you the best advice. All right, so if you did something and it's not 100% on, don't worry. You have just assisted somebody. Somebody had the very same answer, somebody that is in this chat or somebody that is watching online, right? Not everybody is in the chat, but usually we have 100 or 200 persons watching online who are not a part of the live session. All right, so we move into what we looked at just now. I said I was going to do something. All right, we looked at vital capacity just now. So we are going to be looking at the fish scale. And this, while we spoke a while ago, while we said those definitions are more for the HSB student, this now is for the persons who are doing biology. All right. So if you are doing biology, we want to talk a little bit about the fish. And as we spoke about, the first thing I want to bring to fore is the alveoli, as it were, in human, being the respiratory surface. In the fish, can anybody type in the chat and tell me what is the respiratory surface for a fish? Just type in the chat. It doesn't matter whether you're wrong or right. Just give it your best shot. All right. Your wrong and right session will come up when you are doing CXC. All right. That is what I expected. Tanisha, I'll give you a second chance. Tanisha, I'll give you a second chance. Oh, whoa. I didn't answer your question, Tanisha. All right. While I give you a second chance, let me answer your question. You wanted to know, in anaerobic respiration, would oxygen already present in the cell? Would cell move out the cell since there is no oxygen available? Let me see if I can assume what you're saying. You're asking the question, being that you have used up this oxygen, you want to find out now Now that the body is carrying out anaerobic respiration, you want to find out if the cells have no oxygen at all. That's what you're saying? That's what you're saying? If that's what you're saying, for the particular reaction, there might not be any oxygen, right? But we will have somewhere in the body, very low, a small amount of oxygen. Now, let me help you to answer that. Even while the body carries out anaerobic respiration, can you account for the fact that we're still breathing? So you ran that 500 or 5,000 race around the field and you did collapse, but it doesn't mean that you'd stop breathing. No, you were still breathing. It's just that you just did not have enough oxygen. All right? So in some cases, in some areas, you just can't do as you should with the oxygen for respiration. All right? So it's not to say that, listen to me, I stop breathing, there's no oxygen inside. It's just carbon dioxide or something like that. All right? Tanisha, I thought the oxygen would move out of the cell through diffusion. I don't think that I'm understanding you. You're using the old law from the thorax versus the. Look here, let me help you there. I am going to use another thing to answer you. Probably I use something different to answer you. Oxygen and carbon dioxide, they are always going to move based on a concentration gradient, right? When we started out and we spoke about, let me find that, I think we covered that in the lesson today. We spoke about, I think we spoke something about the alveoli, but it was covered earlier in the lesson as to how oxygen actually move versus how carbon dioxide move. I think I did cover it somewhere in the lesson, and I did say it's about a concentration gradient that would cause the oxygen to move when we spoke about the air sac versus the capillary, when we spoke about the carbon dioxide in the plasma versus the air sac. So you could use that to, of course, assist with answering diffusion law. There we go. So once the concentration, the diffusion law, right? Once the higher concentration, it will move. All right. But remember, why would it be moving out of a cell and while it is within that same cell? If this is a particular circumstance, this oxygen would have been used for aerobic respiration. So as soon as it is depleted, then we wouldn't have any oxygen moving. However, in the case of photosynthesis, we're going to have some oxygen moving. Even while we have anaerobic respiration taking place, we're still breathing in. So we're still going to be getting some oxygen inside. If we weren't getting any oxygen inside, we could kickstart the recovery process so quickly. All right, but it's a beautiful question. Beautiful question. All right, so we want to revisit that which you said earlier. I'd asked for the respiratory surface, and I was very deliberate when I'd asked the question. Now, there's a respiratory organ, as it were, for human, the lungs, right? And in the lungs, the respiratory surface is going to be the alveoli. The respiratory surface in the lungs is going to be the alveoli. Now, the gill is going to be that respiratory organ, but within that gill, you are going to have what is called a gill lamellae. And the lamellae is going to be responsible. It's going to be that gaseous exchange surface or the respiratory surface. Not too sure what you want to call it. Now, gaseous exchange occurs, of course, in the gill. And the particular place that it happens is in the gill lamellae. Now, a fish tend to have 4 gills on each side. You'd understand they have it on each side. And of course, each gill will, of course, have 2. Oh, lamina. I say lamina. You have a typo, so it's laminae. All right. All right, guys, are you still with me? We are talking about the fish and the respiratory surface, and this is particularly important for the guys who are doing biology. Now that we would have known about the gill lamellae, we would have understood but the respiratory surface, as it were, for human, the characteristics for this, the lamellae is going to be the same. It's very important for you. I'm not able to show you right now. It's very important for you if you're doing biology that you are able to draw and label the gill. What I wanted to point out for this lesson is that the respiratory surface for the fish is going to be the gill lamellae. And of course, this big organ, the gill, is going to be responsible for the gaseous exchange. Like the lungs is the big organ, however, we have the air sac. All right, pretty much it's the same thing. All right, so we move closer to the end. I don't know if you are pressed, but if you are pressed, that would be fine. I could do, or I think I should, because I don't want to overload you with stuff. What I'll do the effect of cigarette smoking in our next session. Because we're way over the 2 hours. We're like 16 minutes over the 2 hour, and the show is usually 2 hours. So I'll do the gaseous exchange, and sorry, the smoking, the effect of cigarette smoking. I'll do that in our next session. But we want to look at a plant. The gaseous exchange organ there is going to be the leaf. All right, so that is very important to note. And of course, the gases, they are going to be moving in and out through the stomata, as the gases are going to be moving through the gill lamellae, as the gases are going to be moving through the alveoli. That is true. Now, for non-flowering plant, for non-photosynthetic part of the plant, when will be the next session, sir? Okay, beautiful. All right, can I ask you some guys from there? How did you know about the program? Just share with us very quickly. We're going to bring the show to an end now, and we're going to pick up on in the next lesson. I realize that the numbers are falling, so persons probably have other engagement. And I am over time because it should have completed from 7 and I'm in year 8, so we can't carry the full show, come to think of it. The next show, we have shows on a Friday at 5:05, on a Wednesday at 5:05, on a Sunday at 5:05. If the show on a Wednesday is not completed, we usually have another show on a Thursday. We're not going to be having a show Monday. The show will continue on a Wednesday and Friday. However, if we have to go Thursday, we usually ask the permission and rejoin on a Thursday. All right. The Susas, the guys from there, how did you know about the show? You want to share with us? Thanks very much, everyone, for joining. Persons from the many islands. Just let me see if we have all the islands here today. Are you from Guyana? Tanisha is from Guyana. So Tanisha, Otisha, you are here. Otisha, you use so many phones. Otisha is out of Guyana. Jawawan is out of, I was looking for past papers on YouTube, HSB past papers. That's how I find the channel. Oh, I thought you heard our town cry in Olaba yesterday. We were in Olaba yesterday with town cry and in that area. Very good. All right, we want you to share this past paper with your classmates, and we want you to use the past paper. And I told my classmates, beautiful. So, and tell us if you want us to help you with anything else. We'll be too happy to help you. The bio students, I want you to tell the bio students at your school as well. There are many videos, and the integrated science students, they can join. I want you to tell the students at your school that we have all 8 labs for biology on the channel. They could come to the channel, look at the channel, and you could tell your teacher about it as well. We are open to criticism. Please leave a comment at all time. All right, and on my end, 6:05. All right, so the guys who are in St. Lucia or St. Lucia or St. Vincent and the Guyana, they have time at 6:05, and we start here at 5:05. But depending on where in the Caribbean you are, the time will be a little different. I don't know much about the subject. Started since November. You're in grade 10? This also, you're in grade 10? All right, if you are in grade 10, welcome. You are going to be doing a SBA this year. Oh, you're an adult learner. All right, beautiful. You're at the right place. We have Amor is an adult learner. We have a lot of adult learner here. That's fine. You're at the right place. All right, good. So we have a lot of persons here. Guyanese, you are well represented. St. Vincent, St. Lucia, Trinidad and Tobago. Oh, it's later for you, Jawawan. It's 7:05. Okay, so Guyana, the show comes to them at 6:05. Jamaica, it comes to Jamaican at 5:05. Guyana, 6:05. Trinidad, 7:05. Oh, wow. So it must be very late now. I see. That is why we happen. All right. I am really sorry for what happened, but I'm really happy that we're all here and we're here to share. Now, we're not able to cover the show in its entirety today, so we're going to continue on Wednesday. We're going to, again, let me just remind you what we're going to be doing on Wednesday so that you can do your reading. We are going to look at the effect of cigarette smoking on the respiratory system. We are going to complete the systole and diastole. So it's a little bit of everything. I'm very sorry. We're going to be looking at transporting plants. And of course, we're going to, I hope we have all time to do that. And then we want to look at the skeletal system for everyone. Now, everybody needs to know about systole and diastole. I'm going to be doing a video on immunity because there's so much to know about immunity and it's always on every paper, just like the Punnett square or the pedigree chart, not the pedigree chart, the Punnett square or the genetic diagram there, then it crosses always on a paper. There's something about genetics on every paper. Yanni Boo, I'm doing that topic in class. Which other topic you're doing in class? Yanni Boo, which school are you again? There as well? Transporting plants. Okay, yeah, you're supposed to be somewhere around transporting plants. All right, beautiful. So you want to be at the class for Wednesday. It's going to be an awesome class. I think most of my students will be here because we're doing that in class as well. All right, so that's going to be the show for today. I can't say, oh, St. Mary, St. Mary. Do you know Mr. Chen, agri teacher? Yanibu, Mr. Chen? He's from St. Mary. All right, so Yanibu, I want you to share with your classmates over there in St. Mary. Mary Mount. Oh, okay. I wanted to share with your friends over there, sir. I will be here on Wednesday. Beautiful. Come as many times. And remember, there are many videos on the channel. So you are an adult learner. You don't know much about the subject. We have some starter videos by day. We're going to be putting them. You could go to the HSB playlist on the channel. And they have all the videos that we have done so far. Characteristic of living things, I think, is the first thing for you. I think it's in a pink or purple color. And then we have cells. So you want to go and start watching those videos. All right. All right. Yes, it's my pleasure, D'Souza. Thank you again, guys. Thank you again. Thank you again. Thank you again. Thank you again. Thanks a million. Remember to share. Remember to like. Remember to subscribe. Remember to watch the videos to the end. If the video them not worth nothing, leave it in the comments. So, sir, when you come to the live, so, sir, we need to shape up with this video. We need to do that. We need to do that. We would have observed that the first set of multiple choice paper we sent out, the font was very, very small. And then we got some feedback and we made the adjustment. We are going to be putting out some new videos. I'm always telling you about new product where we're looking at the differences among, we're looking at the differences between or among things. So look out for that. Where there are things to be compared and it's giving you a problem, we're going to be having short videos on that. We have the cell, I think it's properties of enzymes. We have that video ready and we're going to be sending that out probably sometime tomorrow. And we're definitely going to be looking at the paper too that is popularly requested by a number of students. This Friday, I think the 29th, the HSB students should go to the exam room. Again, I want to wish for them all the best. They are going to use this time and prepare. We can't do any past paper this evening because it's pretty late. So hopefully on Wednesday, if anything, we are going to be stopping the show and do some past paper. I'll at least work the past paper online with you for 2016 and do the explanation in that live class. All right, I'm very grateful for being here, for you guys being here. I'm very happy that I had the opportunity to serve. All right. So again, when you leave, go up on my channel, go to my channel, and look for the ads that we put up last. Put it on your status. Everybody put the ads that we have up last. Put it on your status. The persons right across the place can see it, and our number can continue to grow, and we can continue to serve you. I'm leaving now. All right, Alia, take care. Bye. All right, my earphone is off, so I'll be out. Take care. Oh. Water. Adios, Tanisha. All right, so that's it for the show. It looks like some people want some more show. Should I go on? You guys want to do past papers? The number is going up. I don't know. I thought that you guys were leaving, but I realize now that the number is going up instead of down. All right, tell you what. Thanks much for joining. We're going to continue the show on Wednesday, and on Wednesday we're going to be doing a part of the 2016 paper. All right, take care. Bye-bye.